Okay, so in the last video we learned how to find the inverse of a square matrix. Now we're going to be able to solve a matrix equation using inverses. Okay, so what you have here in this image is what is called a reciprocal roof. That each one of, like this is a self-supporting roof structure where like there's no supporting beams coming up to it. This is from the bottom looking up at it. Each one of the beams is supported by the one that's underneath it. It's called a reciprocal roof. And that word reciprocal, as far as multiplication goes, is associated with the multiplicative inverse, which is why I chose that picture. Okay, so here is a matrix equation. So in general, matrix equation can be written by A times X equals B, where they're all matrices. All those capital letters are matrices, okay? So what I'd want to do is solve this equation for X, right? I'd want to solve it for X. So ordinarily, you'd want to just divide that thing, both sides, by A. But there's no such thing as division with matrices. So you cannot divide by A on both sides. Doesn't make any sense. So instead, what could we do in order to get around not having division? Well, we're going to multiply both sides by the inverse of A. Okay? So here are the steps involved in solving this matrix equation for X. So I have A that's on the that's being multiplied times X. I need to get rid of it. In order to get rid of it, I need to multiply both sides by its inverse. Notice that I have to multiply it on the left side because this is not commutative. A times X, let me back up. A times X is not commutative, so I can't multiply it on the right-hand side. I need to multiply it on the left-hand side. If I multiplied the left side of the equation on the left, I need to multiply the right side of the equation on the left side as well, okay? Because it's not commutative. Okay, so right here on the left-hand side, the inverse of A times A, those cancel each other out, giving us the identity matrix. Okay, and then further, one more step here, the identity matrix times X is just X itself. So in order to solve a matrix equation, you're just going to multiply by the inverse of A on the left-hand side of the equation. Okay, making sure that you do it on the left-hand side. On the right-hand side, the matrix multiplication may not even make sense. Okay. So, since matrix multiplication is not commutative, you have to always remember to multiply on the same side of the equation. So let's give this a try on this example. I'm going to solve this for X. Solve this matrix equation for X, and X is just another matrix. It's being multiplied by this matrix right up front. So in order to get rid of it, I need to multiply by the inverse. Okay? So, here we go. X is going to be equal to the inverse of 3, negative 2, negative 7, 5, and I write that with a little negative 1, times the matrix that's on the right-hand side of the equation, negative 2, 4, 3, negative 1. Notice that I multiplied it on the left-hand side because really I would have multiplied this one on the left-hand side as well. Okay? Alright, so let's just continue with this multiplication. So I need to divide everything inside of the inverse by its determinant. So 3 times 5 is 15 minus negative 7 times negative 2 is a positive 14. Hey, that's pretty handy because that's just going to end up being 1. Okay, now I need to scramble up all the numbers in this matrix here. So the 3 and the 5 switch places, so 5 and then the 3. And then negative 2 and negative 7 switch signs, so positive 2, positive 7. Now I'm going to multiply that by negative 2, 4, 3, negative 1. Okay, this is just the number 1. And, you know, so it's like I'm not even doing anything to that. That's actually a nice thing to happen. So now let's just do our matrix multiplication and we'll have our answer. So row times a column, add them up. So 5 times negative 2 is a negative 10 plus 2 times 3 is 6. Okay. And going on to the next element, 5 times 4 is 20 and 2 times negative 1 is a negative 2. Okay, now moving on to the second row, 7 times negative 2, negative 14. and 3 times 3 plus 9. And then finally, the last row, last column, 7 times 4, 28, and 3 times negative 1 minus 3. So our final answer is a negative 4, 18, negative 5, and 25. There we go. We have just solved our first matrix equation. That was fun. Let's do it again. Let's do it again. Well, actually, you're going to do it again. So on this exercise, solve this matrix equation for x. Pause the video and give it a try yourself. All right. Was that one maybe a little bit trickier than the one we did together? Let's see what you came up with. So our final answer should have been the matrix negative 1, negative 2, 4, 1. Okay. Now, I'm going to point something out, something that might help you. We're going to talk about it a little bit more in the next video or the next objective. But whenever I went to find the determinant, which is what I have to divide everything inside the inverse matrix by, I get 1 over negative 24, okay? Which means I would be, if I look at this step right here, I would be distributing that to everything inside the matrix, which would make some fractions in there, some pretty scary looking fractions, which I would then have to multiply times the other matrix, 8, 9, 24, 6. Okay? In order to make it easier on you, the scalar multiplication doesn't have to be done until the very end. And that's why I just kept carrying this 1 over negative 24 out front. I just left it out there. I did the matrix multiplication with these two, so that, like these two right here, so that I didn't have to deal with the whole set of fractions until the very end. So again, I have it out here, and it wasn't until that last step, after I've done the matrix multiplication, that I divided everything inside that answer by negative 24. Okay, made it a lot easier to do. Okay, so that wraps up solving a matrix equation by multiplying by an inverse.